Welcome to the excavations lesson. I'm going to be doing various activities throughout this presentation, so get yourself comfortable. You're going to need a pencil and some paper. You're going to need a 8.5 by 11 sheet of copy paper, and you're going to need a couple sheets of regular lined paper, a sharpened pencil, and a sharp mind and an intense focus on the topic at hand, which is going to be excavations. So we're going to learn about how to be safe around excavations and inside of excavations. And we're going to start with a video, which I think should show you some of the risks that exist. And let me do this one here and play.
Who's in charge today? Huh? Who's in charge today? How you doing? I'm in the state of Oregon, OSHA. Looks like you got a little bit of a shoring problem going on.
That's what we're installing right now.
Well, he can't be down there.
Okay.
How are you going to get him out?
Shoring or what? Jim, just unhook that thing. Sorry.
You want to see why he can't be down there? That's why he can't be down there.
It's still sheets you gotta go in.
Okay, you got to get him out. And I hope you get him out soon.
Come on.
How long you guys been working here?
About 3 hours.
Okay. How deep are you there?
About 21 feet.
Okay, you heard him correct. 21 feet deep. So to give you perspective on how deep that is, take a look from the floor to the ceiling in the classroom you're in. That's between 10 and 12 feet. So when they say they were 21 feet deep, that's a huge excavation to have a worker inside of without adequate shoring to protect the worker from cave-in. So let me get this presentation rolling now. We're going to be doing excavations. Excavations, basically, the definition of an excavation is anytime you dig in the ground, you're creating an excavation. The most common type of excavation is a trench, and typically you'll see trenches run for various things. Could be a water line, could be utility line, it could be a gas line or a sewer line. You'll see them oftentimes along the roads when they're retrofitting or upgrading a sewage system or something like that. You'll see a lot of big equipment and workers. Oftentimes you'll notice that your drive is a little delayed because of the work zone that's taking place. So we're going to be talking about being safe in excavations because it's a real risk. It's something that you need to be aware of, and you need to know what precautions you need to take so you can keep yourself safe. So I got 10 questions here. This should be no mystery to you what you're going to do. You're going to pause the video at this time and write down these 10 questions. You're going to be finding the answers to these 10 questions as you watch the video. So please go ahead and pause the video, take the questions down, and when you're done, resume the video. Excavation hazards. The greatest risk at an excavation is a cave-in. That is the number one thing you want to avoid because that is the number one way that people die in excavation. So just make sure you're aware of that. That's a question on your sheet, so make sure you get that filled in correctly. Other hazards include asphyxiation due to lack of oxygen. That's just suffocating, basically, running out of oxygen. Inhalation of toxic materials, potentially a fire. Believe it or not, there can be a fire in a trench or an excavation. Moving machinery near the edge of an excavation, and accidental severing of underground utility lines. Those are all real risks But the biggest and the most dangerous risk, of course, are cave-ins. So injury and death. Excavating is one of the most dangerous construction operations. Most accidents occur in trenches 5 to 15 feet deep. So that's where you'll typically see most accidents. There's usually no warning before a cave-in. And a lot of people think, it's not a big deal, it's just dirt. But the weight of a cubic foot of dirt is over 100 pounds. If you get a cubic yard of dirt landing on you in a trench, you're talking about a car landing on you. And you can't move a muscle. And you're going to have about, I don't know, a minute, maybe two, until you run out of oxygen, and then you're dead. It's also typically very cold in excavation. So your loss of heat, even if you aren't completely covered, you still struggle because you'll lose so much heat in your body that hypothermia can set in. And so extremely dangerous situation in trenches. So how do we protect workers? There's several things that we're going to learn today about protecting workers. Before we do, I'm going to need you to take these definitions down. This is another one of your questions. So pause the video and write down these excavations, because these are important definitions that we'll be using, important words. And when I use them, I need you to be able to understand what they are. So go ahead and pause the video and write them down. So the focus of the training, number one, is to talk about the greatest risk at an excavation, which we know is a cave-in. We're going to talk about how to protect employees from cave-ins, factors that pose a hazard to employees working in cave-ins, and the role of a competent person at an excavation site. And we've been talking about a competent person throughout this whole OSHA training. This person is the one who knows the risks and the dangers that exist on a construction site. They're also the person who knows how to protect workers. So they have the authority in the company to stop work and to make sure that things are fixed before work can continue. So we're going to talk about that competent person as well. Employees should be protected from cave-ins by using an adequately designed protective system. Protective systems must be able to resist all expected loads on the system. And you'll find that the protection of employees inside excavations is very similar to protecting workers in fall situations. You remember that in fall situations, nets need to be able to withstand 5,000 pounds of materials and things like that land on it, plus the worker. So, and that's for each worker. Well, it's the same with excavations. The expected strength of the shoring system or the shielding system has to be able to withstand the worker, but also all of the equipment and materials that might be working alongside or near an excavation. So this is what the requirements of a protective system. This is what they look like. A well-designed protective system, number one, either has a correct design of sloping and benching, or it has a correct design of support systems, shield systems, and other protective systems. So it has one or the other of those, plus it has appropriate handling of materials and equipment, attention to correct installation and removal. And if you put all of those things together, you will have the protection of employees at excavations. So, so you either have sloping and benching systems, or you have shielding and shoring systems. And then you also, with those two systems, you still need to handle materials and equipment so that they don't pose a threat to workers in excavations. And you also have to install and remove those items properly. And if you can do all of those things, then you can protect workers. So an employer shall select and construct either slopes and configurations of sloping and benching systems, or they shall select a support system like a shield or a shoring system. The difference between a shield and a shoring system is not real, great, but I'll give you the definitions anyway. A shield is something that can be permanent, but it also can be portable. It's known as a trench box or a trench shield. And shoring is something you put in, such as like a metal, hydraulic, mechanical, or timber shoring system that supports the sides of a slope. So a shield is like a sheet of metal that is put into the earth that protects you from dirt falling in on you. And a shoring system wouldn't necessarily have to be a sheet of metal, but it would be something that will give the slopes, the sides of the trench, some strength so that they won't want to just collapse in. And that can be either hydraulic, mechanical systems. It could be the use of wood. Believe it or not, you can use timbers even to hold back the walls of a trench, and that would be more of a shoring system. And if you don't use any of those, then you can slope the sides of an excavation. Not many people, contractors, use this because it's expensive, but in a sloping situation, you can remove the edges of a trench so that there isn't a vertical face on your trench. It's actually an angled face, and it slopes away from the trench so that there's no way that there would be any material to fall on a worker. It just wouldn't be possible. But the problem with that system, with this sloping system, is that it's hugely expensive and time consuming. And so a lot of contractors will avoid this particular approach because of the expense. In some situations, the soil is so unstable, they have no choice but to slope the terrain or the excavation. Whereas these two systems are adequate in most situations and probably the fastest to use. So here's a picture of what a proper box looks like. You can see that the worker has a ladder here, a way of getting in and out of the protective system. It's an engineered, approved trench cage. They've sloped the edges of the trench at a 45 here, just to knock off that little bit that might fall into the box itself. So you can see that this worker is in good shape, very protected. And so this is what you want to be working in if you're working in an excavation. This is something that you don't want to work in. You can see that they have inadequate support posts and egress access. What that means, egress access means there's no way for a worker to get in and out of this trench other than to walk down this slope. And in an excavation, workers have to have a ladder or some way of getting out every 25 feet. A worker should not run more than 25 feet or walk or whatever to get out of an excavation. It should be within walking distance, and it should be within 25 feet. That's the magical number. And so you can see here, this excavation not only doesn't have the proper supports and proper egress for workers, but it also is right on a street, and there's no barricading around this. A kid walking down the street might fall in that trench, and then you've got a falling hazard on your hands. So definitely not acceptable by OSHA standards, and something that needs to be addressed right away. Another situation, this worker's in a trench with no protective system, so there's no shield system to protect him. There's no shoring anywhere on this trench. They haven't sloped the sides of the trench away so that the dirt wouldn't fall on him. And you'll notice all of the dirt here that they've removed from the trench, they just put right on the side. These are called spoils. And you can see that all the spoils from the trench have just been set literally right on the edge of the trench, which puts a ton of weight, literally tons of weight, right on the edge. And if the edge was to give way, it would completely cover that worker, especially if he's down here in the steeper end. And no ladder. You notice there's no way of him to get in and out. Every 25 feet, you got to have a ladder in a trench. So there's some factors that are involved when you design a protective system. These are the factors that go into it. Number one, soil classification. That's just what type of soil are you digging in. If it's sandy soil, it's not going to be real great. It's going to want to fall in and collapse. If you're digging in a clay-like material, something that's real stiff and rigid, then chances of a cave-in are a lot less likely because of that type of soil. So your soil classification is going to be a factor. The depth of cut, how deep are you going? The water content of the soil, how much water is in there, because water makes dirt a lot heavier and makes it want to fall. The forces of gravity apply a lot greater to wet soil than to dry soil. So then other things, changes due to weather and climate. If it starts raining, that's going to be a problem if you're inside a trench. And other operations in the vicinity. If you've got big equipment, you got a lot of vibrations or something like that in the ground, that could cause the walls of a trench to loosen, break off, and fall. So definitely some things to consider. Shoring. So obviously, that shoring is one of the systems used to protect workers in excavations. It provides a framework to work in, so it basically provides a safe environment. Typically uses wales, cross braces, and uprights, and its design is to support excavation walls so that they don't fall in on workers. OSHA tables provide shoring data so that the competent person on the job site is the one who probably knows where the OSHA tables are and knows how to read them, and then knows how to apply them so that workers are safe. But there are some tables and some very clear instructions on how to build a shoring system. So obviously, anyone who builds a shoring system, that competent person must know the soil type. They must know the depth and the width of the excavation, so how deep and how wide is the excavation. And they obviously must be familiar with those OSHA tables. You can see here as a trench shield was built around this work area. You can see that worker that's in there. By the way, the height for protection, if you're going to get into a trench over 5 feet deep, you need some form of protection. If you're going to get into a trench that's over 5 feet, you have to have a protective system in place. And you can see this one here. You can't see the ladder, but these are the rails of the ladder right here. So there's a ladder that goes down. There's a worker inside there, and the walls of this box here, this shoring system, is protecting this worker so that nothing could fall in on him while he's down there. This is a hydraulic system that they drop in place. Really cool, because these rams here, these hydraulic rams, when hydraulic fluid is pressed through the system, the rams expand, and then they squeeze against the walls of an excavation, and they hold the walls of that trench in place so that they can't come down. And then after they put all that pressure on those rams and they get it right where they want it, they have some safety pins that they put in there, and that just keeps the thing locked in place in case there was a hydraulic failure, which sometimes happens with hydraulics. Then you would have a secondary safety feature built into the hydraulic into the system so that you wouldn't lose your safety shields. So materials and equipment must not be damaged. They must not be in bad shape. If the equipment is damaged, obviously it's the job of the competent person to see that it is taken out of use. If it's in good shape, that competent person would be the one to determine that. And if it's not suitable, it has to be taken out of operation. And a professional engineer, let me go back. You notice here it says a professional engineer approves it for use. So it can't just be, the boss shows up and decides he wants that box back in use. No, it has to be an engineer who looks at it and says it's safe for use. So protection from vehicles. Another hazard in excavations is just having vehicles fall into trenches because they're not adequately marked, or you don't have someone with a hand sign that's stopping people. So one of the things you can do to protect vehicles from falling in excavations is just install barricades or have someone there with signs. You can fence or barricade trenches if they're left overnight. And they have these really cool solar signs now that you probably have seen if you drive on the freeway and you see the yellow arrows pointing for drivers to get into a different lane. Well, they have those that can be placed in near excavations to alert people that there's an excavation there, don't drive by it, and they're solar, so you don't even have to plug them in. They're just incredible. So there's different things you can do to protect vehicles from falling in those trenches. This one here is dangerous. This is a vehicle that is literally a tractor, that's an excavator that dug this hole here, is literally straddling this trench. And if you look down here, there's 3 workers there, at least 3. It looks like 4 workers down in that trench. And if a worker is 6 feet, just take a look at the depth of that trench right there. That must be 21, 22 feet deep. And those are sheer walls. That's straight up and down excavation. And if these walls gave way from the weight of this tractor, creating vibrations, those workers have no chance of survival. I mean, none. I don't care if they're wearing hard hats. That's great. That's super PPE in case one of these boulders falls, although that wouldn't do them good anyway. But if these walls of this trench fall in on them, they're done. There's no way of getting them in 2 minutes to protect them. Plus, the weight of that material might just crush them anyway. So very hazardous situation. Don't ever get in a trench that looks like this. Okay, so spoils, again, don't place your spoils within 2 feet of the edge of an excavation. You can see here that they've got spoils all the way up to the edge of this excavation. You want to make sure that you've cleared the spoils and all the stuff you've dug out of the trench away from the side of it, at least 2 feet. You want to place the spoils so that rainwater runs away from the excavation just in case it rains. You don't want to have a bunch of water in your excavation for a number of reasons. It's just not a good idea. So some other excavation hazards, you got water accumulation, which we'll talk about in a second, oxygen deficiency, toxic fumes, access or egress, getting in and out of a trench is a big deal, falls into a trench, and then mobile equipment. So water is hugely dangerous in a trench. Number one, it makes it hard to get in. It makes it hard to get out. It makes it hard when you're in there. There's a possible potential hazard called trench foot, which a lot of soldiers actually got in World War I, because a lot of the fighting in World War I was trench warfare, where they basically lived their life inside trenches. And the trenches would fill up with water, and the soldiers would be in the water for hours and hours and hours. And believe it or not, their flesh would literally rot off of their bodies to where the only thing left was bone. That's called trench foot. And obviously you wouldn't spend months and months and months in a trench, but you can still do damage to your flesh if you stay in a wet environment for any length of time. So you want to make sure that you stay out of trenches that have water in them. Also, if you strike an electrical conduit inside a trench, you will electrify all of the water inside the trench. So basically, water is hugely conductive of electricity, and anything or anyone in that water would be electrocuted. So definitely not a good idea to be in water in a trench. Also, notice this picture here. These guys are struggling to get out of this trench. They're muddy. They're messy. They don't have hard hats because they're in deep enough that if something fell on them, that could be another source of injury. And they have no means to get in and out, no ladders at all. So not good. Another situation, these workers are working in an area where there could be a cave-in, because when you have water in a trench, all of a sudden the sides of that trench, the walls of that trench become unstable and potentially could come down on the workers. Plus, again, water conducts electricity, and so staying out of trenches that have water in them is a very good idea. Hazardous atmospheres, what this means is in some excavations, and even if you go inside something like a sewer manhole, it's a good idea to do some testing before you get inside that trench. The reason is because some gases are heavier than air. What that means is you can dig a trench 15 feet deep, and the first 10 feet of that trench is all methane gas. If you get inside that trench, you will not be able to breathe, and you'll get sleepy, and you will lay down and fall asleep inside the trench and die ultimately from oxygen deficiency. So you want to make sure before you go into a trench that you test. Anytime you get a trench deeper than 4 feet, throw a little tester. They've got testing probes that it cost a few bucks, and you throw the probe in there, and you hold the device in your hand, the testing device, and it'll tell you what the makeup of the air is in that trench, so you can be sure it's healthy for you to go in there. Costs a couple bucks. It's worth your life. And then you're sure that what you're getting into is something that you can also walk out of. There's a fatal fact that I wish I had with me right now, that of a couple brothers that are working in construction. They're digging a trench, and the brother that's running the piece of equipment notices his brother inside the trench laying down, and he assumes that something happened, or somehow he becomes concerned and jumps out of the tractor and runs down there to save his brother, and discovers that there's oxygen deficiency, and he also dies in that trench as well. So when you see someone in a trench and they're laying down, if that happens, don't necessarily run in there to try and save them, because that could cost you your life as well. So understand also that gases are combustible. Like methane gas is a combustible gas. So you could potentially, do something like strike a rock or something, and that would spark potentially an explosion. So you want to be sure that you understand that there's a chance for explosion inside trenches, and then other hazardous substances can also be present in trenches. Means of egress, again, we talked about this, but you need to have a ladder that extends 3 feet above the height of an excavation, so that when you climb out of that excavation, you can step onto the earth. You don't want to crawl onto the earth. You want to be able to walk out of it standing up. So this ladder here obviously does not meet that standard. A stairway, a ladder, or a ramp must be present in excavations that are 4 feet or more deep, with 25 feet and within 25 feet of employees. That's a critical number. 25 feet away from every employee. So if it's a 100-foot long trench, then every 25 feet, you're going to have a ladder. That would be 4 total ladders in that trench. This is not adequate. Obviously, they've taken 2 ladders and they've tied them together. They've lashed them together so that they had a ladder that was tall enough. That's not acceptable by OSHA standards. So you got to have protection from falling loads, mobile equipment, and from people falling into trenches. You install barricades. Those are high visibility signs, basically, that tell people that there's a excavation there. Use hand and mechanical signals. Fence or barricade trenches left overnight. Obviously, you know that. Use a flagger when signs, signals, and barricades are not enough. You want to become the competent person. Believe it or not, it sounds like there's a lot of responsibility on that person, but if you become the competent person, that means you're respected, you're knowledgeable, you know how to keep people safe. So becoming the competent person is something that I hope you guys all aspire to become. This person has specific training about excavations, and they understand soils, different types of soils, and the use of protective systems. They know how to install them, and the requirements of OSHA to meet the standard for excavation protections. They must be capable of identifying hazards, and the crucial word here, authorized to immediately eliminate the hazards. That's a very important aspect. It's not good enough just for them to know the hazards, but they have to be able to have the juice, the authority to eliminate hazards that are found on job sites. The competent person must also make a daily inspection of the site just to make sure that everything's good. Excavations are appropriate, and they should also inspect before work starts every day. Anytime there's a rainstorm or high winds, they should stop and inspect everything again. I'm going to go ahead and play another video real quick. So let me pause this and then we'll get back into this. 1 second. Here we are.
In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills on average 40 workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows how quickly cave-ins lead to workers' deaths. The video will also show what employers must do to assure that the work can be done more safely. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll see that using the right type of protection saves lives. Please be advised, the scenes you're about to see deal with deaths at construction sites and might be disturbing for some people. All scenes are based on true stories. 5 workers were putting a sewer pipe into the bottom of a trench with a ladder nearby to enter the trench. There was nothing in place to protect the workers inside the trench if the walls collapsed. While the workers were inside the trench, one side began to collapse. 2 workers were able to climb out using the ladder, but the other 3 workers were buried in the soil and unfortunately suffocated to death from the weight of the soil. Let's look at the events leading up to this tragic incident and see how it could have been prevented. Employers must follow OSHA rules to protect workers in trenches. However, here, the employer did not follow OSHA's rules, which led to these workers losing their lives. Let's go over the main points of OSHA's rules for trenches to see how to keep workers safe. All trenches must follow OSHA's rules. 1 cubic yard of soil can weigh as much as a car, nearly 3,000 pounds. So unless the trench is cut entirely into stable rock, protection against cave-ins must be used for all trenches more than 5 feet deep, or for any trench that shows signs of cave-in. Before workers can do any work in a trench, a competent person must conduct an inspection to identify and remove any potential hazards. A competent person is someone who can recognize hazards in the area and who has authority to take quick actions to eliminate the hazard, which may include temporarily stopping the work. Inspections must be performed at the start of every shift, after a rainstorm, or whenever conditions change. The competent person must also test the soil in a trench. OSHA requires at least 1 test by looking at the soil and at least 1 test by hand. If a person knows the soil types, they can pick the right protective system to keep workers safe when they're in trenches. OSHA classifies soil in a trench as stable rock, type A, type B, or type C soil. Stable rock is the safest soil for a trench. Type A is the next most stable, and then type B. And finally, type C soil is the least stable. It's important to remember that trenches can have different types of soil based on depth and climate conditions. The competent person can choose from different protective systems for a trench, based on the types of soil found. For all trenches deeper than 5 feet deep, or for any trench that shows signs of cave-in, OSHA requires sloping, benching, shoring, or shielding to protect workers from cave-ins. Let's review each of these systems and then see how each one could be applied to the cave-in incident shown earlier. We'll look at sloping first. Sloping protects workers by cutting back the sides of the trench so the sides slant away from the trench. OSHA's rules identify the degree of slope allowed for each of the different soil types. When trenches are less than 20 feet deep, these are the basic maximum allowable slopes for each soil type. Stable rock can be vertical walls, but cannot be undercut. For type A soil, OSHA requires that the walls be sloped 9 inches out for every 1 foot of trench depth. For type B soil, OSHA requires that the walls be sloped 1 foot out for every 1 foot of trench depth. For type C soil, OSHA requires that the walls be sloped 18 inches out for every 1 foot of trench depth. It's important to note that this kind of sloping can only be used for trenches less than 20 feet deep. Any deeper, and the protection must be designed by a registered professional engineer. So now, let's look at the workers in the original scene who were stuck in the trench as it started to cave in. But this time, the soil has been classified as Type B. The trench has been properly sloped, and the spoil pile is moved away from the edges of the trench. The trench walls are not caving in, and the workers are safe while they work. Now let's review the shoring type of protective system for trench workers. Shoring uses various support systems to prevent soil and the trench walls from moving. There are different kinds of shoring systems, but timber and aluminum hydraulic are the two basic types. Aluminum hydraulic cylinders are the most common type of shoring, and they are typically installed using spot bracing, plywood, or stacked methods. To install the shoring correctly, you must first determine the soil type. The type of soil and depth and width of the trench determine the maximum vertical and horizontal spacing used with the members of the shoring system. If we use our example of a 3-foot wide, 10-foot deep, 40-foot long trench in Type B soil, the shoring system being installed would need to include 12 strong aluminum vertical shores, with 6 on each side of the trench. These shores, also called rails, will be connected by hydraulic cylinders every 8 feet along the length of the trench. A hand pump pressurizes the hydraulic cylinders until they fit tightly within the rails. Now that the shoring is in place, let's look again at the workers in the trench at the beginning of the video. As before, the workers are laying a sewer pipe into the bottom of a trench. But now the shoring system prevents the trench walls from caving in and keeps the workers safe. Sloping and shoring are ways to protect the sides of the trench so they don't cave in. Now let's talk about shielding, which is a way to protect the workers when they're inside the trench. Shielding involves using trench boxes, also known as trench shields, or other supports to protect workers inside a trench from collapsing soil if a cave-in occurs. The competent person should pick a trench box that is right for the soil type and all other site conditions. A trench box has 2 large plates, which are held apart by 4 horizontal cross members. These plates, or shields, must be between the sides of the trench and the work area. The shields are strong enough to protect workers inside from a soil collapse. The shields can be 2 feet above the bottom of the trench, as long as they can support the entire depth of the trench and there's no caving under or behind the shield. The top of the shield should extend at least 18 inches above the level of any materials that could cave into the trench. Trench boxes are typically used in open areas, but they can also be used with the sloping methods discussed earlier. So let's see how a trench box could have saved the workers that we saw at the beginning of the video. For our example, we'll assume that the workers are in a trench with Type C soil and no sloping, but working inside a trench box. This time, as the workers lay the sewer pipe into the bottom of the trench, they are protected from any possible cave-ins. This example shows the importance of employers following OSHA's excavation standards to ensure that workers are provided with a safe workplace. These types of construction deaths are preventable. The trench cave-in prevention measures shown here save workers' lives. Use these protections on the job. It could be the difference between life and death. If you would like more information, contact OSHA at www.osha.gov or 1-800-321-OSHA. That's 1-800-321-6742.
All right. So obviously, you know the role of a competent person in determining which method to protect workers is the one to choose. You can see that that person is someone who is well respected. We have a lot of authority on the construction site. And so, like I said, you guys want to become that person. So if the competent person finds evidence of a possible cave-in, The exposed employees should be removed from the hazardous area by the competent person, and employees may not return until the necessary precautions have been taken. Again, it's the competent person that will evaluate construction sites to be sure that they understand the dangers and that they're aware of them. They do these evaluations on a daily basis. Anytime there's been rain or any changes in the workplace that would cause him to inspect. Obviously, you're going to look for low oxygen and hazardous fumes, toxic gases. You want to be sure that you contact utilities. This is something that I haven't spoke on, but I do want to talk about, and that is before you begin an excavation, there's a free service called Dig Alert, and you call Dig Alert, and they will come out and mark on the ground where voltage lines or telephone lines or water lines or gas lines might be located before you do your digging. You don't want to call Dig Alert or Dig USA after you've dug. You want to call them before you dig, because if you hit a power line or you hit a gas line while you're doing your digging and you didn't call them, you're responsible for whatever the cost would be to fix or repair that. So you want to be sure that you call them, and it's 100% free. You go on Google, type in Dig Alert, you'll get their number. You call them and say, hey, I plan on, digging a trench for, electricity to have in my jacuzzi in the backyard. You want to call them a few days before, because you don't know what is in that ground, and you don't want to hit something that might cause you a big bill and potentially death. Or some kind of injury. So just remember that Dig Alert anytime you're going to trench or dig, even in your own backyard. So summary: the greatest risk in an excavation is a cave-in. Employees can be protected through sloping, shielding, and shoring. A competent person is the one who is responsible to inspect the excavations. Other excavation hazards include water accumulation, oxygen deficiency, toxic fumes, and mobile equipment. This is our summary activity. This is the last slide. And you'll see here on the left, we've got a quick card, a job card from OSHA. And this one here talks about heat stroke. This particular one is talking about how to protect yourself on a construction site as it pertains to heat stroke. What I want you to do is make a job card very similar to this one, but you're going to make a job card that can be used by workers on a construction site. It's supposed to be small. It's not supposed to be huge. It should fit inside a construction worker's pocket. So that's how small you're going to make this card. And what you're going to do is, I'll just go ahead and read these instructions. You are tasked with creating a job card that can be used by construction workers on a construction site. Your card should list the dangers of working in and around excavations. You should strive to make your card small enough to fit in a worker's pocket, but have enough information to inform them of the dangers and methods used to protect workers around excavations. An example of an OSHA job card is on this page. Your card should list at least 5 hazards, 5 safety methods, and at least 3 pictures. When you have that done, turn it into your teacher with your questions, and your teacher will give you a quiz. And if you pass it, then you will be one step closer to your OSHA card. I want to thank you for paying attention, and I wish you all the best as you complete your OSHA card. All right, take care. Signing off.